So now, folks, I've got some tweezers because, I'm sorry, Adam, I'm going to be a bit cheeky here, because all of these things, and we're talking about productivity and efficiency with all these machines, we're talking about testing and things like that, but testing's there for a reason. Sometimes things do go wrong, especially if you've invited me here with a pair of tweezers to dislodge one of your components, Adam. So I'm going to do that right now. So follow the tweezers in, folks, as I make the really, really bad decision by changing the component off here and putting it at about a 45-degree angle. You can see there that there's solder patch underneath there. So it's all been changed, folks. That is not a nice thing to do to you and the team, Adam, but I'm doing it for a reason, because we're now going through another machine. Tell us about the machine you see behind us and what stage are we at now?
So we've got to reflow now. So This is our reflow oven, which heats all the components and the solder paste up to 260 degrees.
Right.
Creates that chemical reaction that we spoke about earlier, which forms a solid solder joint.
Right, and this is what it's all about, folks. And you used to have a unit was slightly smaller than this, but actually you've recently put this unit in because, again, like anything that you heat up, you wanted to heat it up gradually, folks, so that therefore everything heats up to the same temperature, and that adds in that quality and efficiency. Even if it's 0.5% of an improvement or even fractions of that, all of this makes a difference when you're talking about the uptime of your control unit to help the uptime of all of the critical things in there, isn't it?
Correct, yeah. So by extending the profile, so a slow ramp is what we call it, that will then increase the longevity of the components. You're preventing a thermal shock happening by just heating straight up to that 260 degrees.
And nobody wants a thermal shock, folks, because I'm hot enough as it is in here. So now time to see really whether my intervention actually can be picked up, folks. So we're off to see the bad man's board get picked up. See you later. So we've just had a good board go through, folks. I'm next. Let's see if I've messed it up enough for the machine to detect it. And let's see how it looks, because, Adam, there's a system here that's going to detect all that through cameras, and it should show us on the screen as well, shouldn't it?
Correct, yeah. So
this is an exciting moment.
So this system here has 15 cameras inside it. Here it is. Has 15 cameras inside it, which create a full 3D image of every single component that we've just placed onto that board.
Right.
So we can see here, your component has been flagged because it's not in position.
That's it, because I twisted it to that extent as well, didn't I?
Correct. We can also see down here, we've got the full 3D image built of that component that we can turn around and look at the full sections of it.
And we can see here, folks, that that whole piece there is where it should be sat on. So that is absolutely brilliant. So, Adam, I tried to mess it up, and I failed, folks. Well, that's what it's all about, isn't it? Checking,
Correct.
Double checking, having these systems, having the camera technologies, having the components all lined up, all put into the right flux, the right solder flux system. And then we've got to now go to the next bit where we're going 180.
Correct.
We're literally going to flip this board, folks. And I'm like, why are we going to do that? We're going to find out in a moment. Come on, Adam, go that way. So now, folks, we're going to take the stack from the previous line and put it into this line. So I've got a stack here full of the components ready to go. So we'll pop it in here nice and carefully. Adam, would you do the honors and press the button, and there, off we go. It goes, come on here, folks. We see it going right down now into the system, which is fantastic. So we're now on the second line, folks, and this is where the board's been inverted with Adam. But we see here the reason why this is a second line, bigger components spliced together again as we're going to start the run now to make sure we've got all the components ready. But specialist casings as well for these products. Why is that the case?
Absolutely. So these cases protect the products from ESD, which is electrostatic discharge.
Right.
So where you get your shock when you touch a metal door handle or something like that. So these components are very, very sensitive to that.
Yep.
So they need to all come in the specialist casings to protect them.
So what's really fun, folks, is now we've got the flipped board with all the components on it. This one's been tested by the same system that we had previously, but all of those components are now on this board and ready to go to the next phase. Super cool. So I'm back here with a coin cell battery that keeps the real-time clock going on the PCB. But, folks, they've let me at it again. So I'm going to do something pretty sneaky. I'm going to put in this one the right way round, and the other one in the other way around and see if the system here, which is a brand new system, fails me and fails this board. Okay, let's go for the first one. Right, so we put that the right way around. Notice coming into that, whoops, that shouldn't be there, it should be the other way around. Now we're going to send it so that we can see, folks, whether the machine will spot that I've been a naughty operator and put this the wrong way around. Right, Adam, I've done something naughty again, putting the coin batteries in. You weren't there at that time, but I've proved the system works at the last time. Let's see if this brand new fault is coming in and this brand new system. This is quite interesting because it's from Falcon, who's literally up the road. Again, this is you as a business supporting local other businesses in your sector, isn't it?
Yeah, absolutely. This is a 2D camera which inspects all the components on this board that we've just placed at the last operation and checks for the orientation to make sure that's correct.
Send it, Adam, send it, go. So as it races forward, folks, you know, for me, this is yet another point in the process of quality and inspection. Let's see how it goes. The moment of truth. Have I put them in the right way round or the wrong way round? Has it picked it up, folks? Little bit of red there. Something has failed. I failed yet again to break the system here at DSE. Time to go and see some more. Right, so this is really exciting now, folks. Live here, we've got a solder fountain actually then coming into the board from underneath where we've seen earlier. This is another clever little thing that we've got here that makes sure that the soldering process works, isn't it?
So we apply a flux, we preheat the board to a temperature, then we place it above 4 solder baths, independent solder baths. They'll track the safest route and the quickest route and optimize the process of soldering the components that we've just placed in.
Fantastic. So who'd have thought I'd have seen a solar fountain today, folks, doing the job. Cheers.